Hello everyone, welcome to the learning session of Ping Z1. So the next experiment what we will discuss is on AI based traffic density analyzer, how it can use AI based traffic density analyzer for on Ping Z1. So along with this we are also going to send the real time detected traffic density values to your MQTT server. This will be the time, and we are installing this using pip install MQTT. So now broker, this will be the broker in which we'll send, and this will be the port number for this. So we are connecting the client using mqtt.client part, and once it is connected it will show us that it is connected to the MQTT broker. Now initially the vehicle count value will be 0 and density global value will be low. The MQTT is in the lock state. Now the YOLO config, we are loading the config values in the weighted values, and we are setting the threshold which is 0.5. And once that is completed, we are trying to whatever the weighted values or the config values what we have, now we are trying to read it using cvt.dnn, so deep neural network. And once the output layer is there, we are trying to show what are the classes of vehicle it has to detect. So car, bus, truck, or motorcycle. These four classes we have declared. And with this, the buffer, what we are trying to share. Yes. So this will is going through a threading part, because as it has to detect this, the it has to we have to give some threading to the HDMI, as once you're detecting, it requires some time to analyze what vehicles it is trying to detect. For that we are using a threading. So once the deep neural network is completed, so what we do is we go to the feed forward output layer, and based on the threshold, whatever the threshold we are getting, if it is greater than the threshold, it will undergo these operations and it is going to append it on a box. The confidence value what it will show is will be in the floating point, and it is going to detect the final value, whatever the final value it is trying to get. So once it is trying to complete, we have to go to the MQTT sender. This is the MQTT sender part, where the values what we are trying to send to your cloud should be the count of vehicles, whatever the vehicles it is trying to detect, and what will be the density value, how much density of vehicle it is trying to see and how many vehicles it has detected. So based on that there is a count, and based on the count it is going to these data is going inside your cloud in real time. So it is trying to publish, client is trying to publish, and when it's published it is going to, this is the function where it is sending on parallel. So the density value and the time values whatever is there, it is trying to send parallelly. We have given some delay of 2 seconds, and this will be the threading for both the YOLO and your MQTT sender. So the base overlay, base dot bit what we have, we are just setting the resolution of 1920 and 1080p, and with this the HDMI out is happening for RGB, and again the camera 1920 1080p. So from this will be the input and this will be the output. It's just taking it as video capture 0. Now once it is completed, the main loop or the detection logic of counting of vehicles and how you are going to draw the bounding box is the question what you will come. So this will be the R, G and B, where you are giving the green value, so it will show you on the green letters for the rectangular box, whatever the bounding box it is trying to detect, and it is trying to put the text, whatever the classes of your detected vehicles will be coming in the form of text frame. So how are you going to determine that the value or the traffic density value is there? So if the count value is less than or equal to 5, the density will be low. And if the count value is less than or equal to 15 of the vehicles, it is going to show the density as medium. And if the count value is greater than 15, obviously it will come to the high state. Now, so MQTT log, we are trying to pass the vehicle count, whatever the vehicle count we will get, it is going directly to the MQTT server. So cloud will be storing these vehicle count values in the density. Density value will be the low or the medium or high value. So once we are putting a text frame in all this, yes, so it is going to give you the new frames and you are going to release the video. So this is how you are publishing this data. So till now the density values uh, was 0 from here. Now we are going to see how it will update on. So this is what is happening. It is trying to detect the car. Next, it is trying to detect the bus, right? And then it is also detecting the car. So the density value what it has detected till now is 3. So the vehicle count is 3, then it is becoming 4. Total vehicles in your picture is 4. So based on that, it is trying to show you the vehicle values, what is the detected values and the config values. Another. So yes, the total number of vehicles which it has detected is 3 cars and 1 bus. So that is how you can say that your density values are getting updated in your real time. So whatever the values, whatever it has detected, number of vehicles 4 and the timestamp for your given value, the density is low. So this is how you can be used for automatic driving assistance systems and for getting the real-time traffic density. for more powerful devices like Zinc Ultrascale and Vertex Ultrascale. As this is a Zinc 7000, it has some limitations, but it can be used for basic AI for learning purpose. Thank you so much. Although with MQTT, you can even use your own APIs. You can create your own apps or applications, create your feed, and get it on your API format also. Thank you.